Hello, my name is Deborah Lopes from Worcester Polytechnic Institute, and I will be teaching you how to use the program ArcGIS to map accidents. First off, I will be teaching you the basics of the program so you can fully comprehend the essential functions. I will be using the software ArcMap version 10.2.2. GIS stands for Geographic Information System, and it is a program that allows the user to construct maps from geographic information.
As you can see on the desktop of the computer, the program is in the shape of a globe with a magnifying glass. After clicking on it to start, after you wait a while for it to load, you will be prompted with the ArcMap Getting Started section. I will be clicking on Blank Map to start fresh under New Maps. However, with this window, you can open up saved maps like the one I have here listed under Existing Maps. But just like I said earlier, we will be using Blank Map to start with a new blank document. Now that the program is open, I will show you some simple tools that you need to know to map and analyze the accidents. It would be best if you follow along as I show you, so you can fully comprehend what this program does. First, I will show you how to import data layers, or more precisely, shapefiles that you need as a foundation for your map. Follow along where I go. Go to the yellow map with the plus sign on the home page. This will prompt you to add data. All my files are saved under a folder titled Shapefiles. I go to Desktop under Look In, then I go to Shapefiles, and this will prompt you with a bunch of different shapefiles. For accident mapping, however, I will need 3 specific shapefiles as a basis. I would need road districts. Road districts is the outline of Namibia, along with all the Namibian regions. I will need Trunk Roads 9, which is all the major routes in Namibia, and I will need towns, which are all the relevant cities along the B1 and B2 highways. Towns was modified to only include the cities on the B1 and B2 highways. There is a shapefile of all the towns in Namibia, so if you need to assess accidents on different routes, don't worry, the file is out there. Also, all these data layers were provided by the Roads Authority. After these data layers were inserted, you can see them under the table of contents on the left-hand side. The table of contents is where you can see all your data layers. It is also where you can select and deselect the data layers. A check mark, as you can see right here, is next to the data layer, means it is visible on the map. A non-check mark box makes it invisible. I will show you now. See how it disappears? You can customize the data layers to arrange which it can be shown and not shown on the map. You can change the order on which they appear under the table of contents layers section. As you see, towns is on top of trunk roads and then districts. To change the order, simply drag the layer you want on top. See? As you can see in the map, it changes the order how they appear. Thus, it is crucial to always have the bigger or the file that is bigger foundation on the bottom and then proceed in that order. So here, with our map, we would want road districts in the bottom, then Trunk Roads 9, and then towns. These files include information that you can access at any time. If you right-click Trunk Roads 9 and select Attribute Table, something like this will appear. In this file for Trunk Roads 9, it includes the actual name of the road that the Roads Authority assigns it under the column Road NR. It also gives the beginning and ending kilometer in begin km and end km. This attribute table provides much needed information that is crucial. Why is it crucial? Because when you are making an accident file, you'll be creating an attribute table similar to this one with information that is crucial for that accident. Next is changing the color of the data layer you want. Simply click on the square or circle or line that the file might be. So for example, I would be clicking on towns, and this prompts you to symbol selector. From there, on the right hand side, you click on color right here, and you can pick any color you would like to change the town to. So I will be changing it to green. From there, you can also change the size. You can change the size by going to the size, and can increase it to anything you like. And you can see right there that is it increasing. So I'll make it 12. I will click OK. And as you can see on the map, these changes are put into effect as soon as you click OK. Understanding this is important because we'll be changing the design of the accidents that we pinpoint. Next, we'll be learning how to use the measuring tool. This is a tool that allows you to measure the distance by drawing a line on the map, and it also allows you to measure areas and features. However, for this project, we're only focusing on the distance. This will be used when plotting accidents because we'll be measuring the distances from a town to an accident location. This tool is located on the home page with the ruler symbol with arrows, right here. After you select it, a small measure box will appear. Now to start measuring, click on the map where you want to measure the distance. For a more accurate measurement, it is best to zoom in using the zoom in function on the home page to have smaller segments rather than larger ones. So I will be zooming in using this function right here, going in. After I have zoomed in, I will measure the distance between Suneb to Ashivela. Click on your starting point. But first, we must get to there. So Suneb is right up here. So I'll zoom in to that section. And once I have zoomed in, I'll measure the distance between Suneb and Ashivela. Click on my starting point, which is Suneb. And I will move along the road and click along the way. And I will zoom in a little bit more. And as you can see in the measurement box, it will display the length of the segment, which is the distance between the last two clicks, and the length, which is the total measured distance. So I'll keep clicking along the way, clicking along the road. As you can see, the more clicks I do, the more accurate it becomes, and the closer it follows the actual road. So some of my segments show as much or as little as 3 kilometers or 0.5 kilometers, but the length keeps adding up. So the approximate length between Suneb and Ashivela would be 98 kilometers after this is completed. Next, I will be teaching you about the geoprocessing tools. We will only be learning one of the geoprocessing tools called Merge. The others are useful. However, for the scope of this mapping, only Merge is necessary. This tool will be used after you have pinpointed the accidents on the map. However, it is important to learn this step now. Thus, to learn this system, I'll be using one of my already made maps with accidents already pinpointed. So I will open up my old map, Namibia Accidents. Before we merge, we will need to extract data from a data layer. There are 2 ways you can do this, and both methods will be used for accident mapping. The first method is to use the select tool on the toolbar. It is blue and white with a cursor. So right here, select it. With this tool, we will highlight the accidents we want to extract. For example, I will be extracting all accidents between Walvis Bay and Swakopmund, so I will zoom into that section. So with the select tool, I will highlight the accidents between Walvis Bay and Swakopmund. From there, after they are highlighted, go to the accidents data layer. Right-click on it and go to Data. From there, go to Export Data. This will prompt an Export Data tab to open. When this opens, make sure you name the file something that you can remember and something that can reference to the data set that you are exporting. So I will name it Walvis to Swakopmund Accidents 2015. Click OK. This will prompt to a window asking you whether you would like to export the data to the map as a layer. Select Yes. This will export the selected data onto the map as its own layer, separate from the accident layers. This will be useful later when you have all the exported data layers and you will need to merge them. The second option to extract data is to use the Select Analysis tool. To locate this tool, we must go to the Geoprocessing tab and click on Search for Tools. This will display a search bar for all tools on ArcGIS. Search for Select. Click on Select Analysis. This will prompt a window with input features, output feature class, and expression optional to appear. In input features, we will input accidents because that is our parameters. From there, we will be naming the file. Remember to name it something that you remember and something that is related to the data set. I will be naming this High Risk Accidents 2015. The Expression Optional tab is what we'll be using to select the specific data we want to extract. There are many functions you can do with this, but I will teach you the three because those are the ones that fall into the scope of accident mapping. Specifically for accidents, we want to note the high risk, medium risk, and low risk accidents for this process. The severity score is what indicates whether it is high risk, medium risk, or low risk. After you've done the data analysis and found the severity score range for low, medium, high, this is when you would divide the mapped accidents. For purposes of teaching you now, we'll assume that low-risk accidents are from 40 and below, medium-risk accidents are 40 to 90, and high-risk accidents are from 90 and above. Click here, SQL, to prop open the query builder. Scroll down until severity appears. Click on it. From there you can select Get Unique Values. However, this is not relevant now because we'll be using the greater than, less than, and equal to functions. Thus, knowing the values for severity scores are not needed. First, we'll be extracting the high-risk accidents. There is a white box at the bottom. Click on it to make sure it is selected. Then click on Severity again. This will prompt it for it to appear in the box. Then click on Equal to and Greater than sign right over here. Don't click 2, only select 1. And then from there, input 90. And then click OK. This will input it into the Expression Optionals tab. Then click OK.
After a while, it will be inputted onto the map as a data layer with the name you gave it. As you can see here, the high-risk accidents are colored in purple. However, for medium risk, you will input as shown here on this PowerPoint slide. You will input severity less than 40 and severity greater than 90. This is essentially building a phrase selecting the data between 40 and 90 severity score. For low risk accident, you will input severity less than 40. This will give you accident data below the severity score of 40. You repeat the same steps for medium and low risk accidents. However, for medium risk, you will input as shown here. You will input severity less than 40 and severity greater than 90. This is essentially building a phrase selecting the accident data between 40 and 90 severity score. For low risk accident, you will input severity less than 40. This will give you an accident data below the 40 severity score. After these data layers are exported onto your map, you can color and change the shape of your data to your pleasing. However, for the scope of this accident mapping, please color low risk green, medium risk yellow, and high risk red. This data will not be used as an example for merging in this tutorial. However, it is useful for merging when you want to construct a map of composite years. Now we will be learning about merging. To reiterate, merging is useful when you want to combine multiple data layers into one layer. For this example, I've extracted multiple data layers, primarily of accents along the B2 route. We've been merging these files to create one data layer for all accents on the B2 route. Thus, to begin, under the Geoprocessing tab, click Merge. It will prompt you to a window with input databases, output databases, and field map optional. We will only be working with the input and output features. For this merger, input Walvis to Swakop Accents 2015, input Swakop to Arandis Accents 2015, Arandis Usakos Accents 2015, Usakos Karabip Accents 2015, and Karabip Okahancha Accents 2015. We will be naming this file B2 Accents 2015. Remember to name this file something that will be useful to identify the dataset. Click OK. This will export the file onto the map. After it is exported, you can change the color and shape of the layer to whatever you choose. And as you can see here, I merged all the files into one file, B2 Accents 2015. Those are all the tools that you will need to know how to use for the scope of mapping accents in ArcGIS. However, one hint before we move on to actually plotting accents on the map: if somehow the table of contents, search box, or any tools on your home page disappear, they can be found under the Customize and Windows tabs. This is extremely useful because sometimes you can delete them from your home page. After you learned all the basics of the ArcGIS system, we will now begin plotting the accents. First, we must create a shapefile. A shapefile is a data layer in GIS that has geographic information along with other attributes for reference. To create a shapefile, go to the catalog on the right side of the page. Depending on where you want to save your shapefile, you can select practically anything. For the purposes of this tutorial, we will be creating a shapefile under Documents. So right-click under Documents, go to New, and then from New, go to Shapefile. This will prompt a window saying Create New Shapefile with name, feature type, and spatial reference. For the sake of this tutorial, we will only be using name and feature type. Under Name, input accent, along with the accent year you are analyzing. For the sake of this tutorial, we will be doing the year 2016. Then for feature type. Feature type selects what type of shapefile this will be. It will be point, polyline, polygon, multi-patch, or the types. For the sake of this tutorial and accent mapping, we will select point. We only want to pinpoint one accent at a time. After that, you click OK, which will prompt up that you're missing GPS data. Select OK, because it does not matter. This will prompt the Accent 2016 to appear under Layers table of contents. This means that you have created a shapefile. Before we begin creating the accidents, we must first establish the attribute table for the information imputation. To create an attribute table, first right-click on Accidents, then click on Open Attribute Table. From there, we must establish fields. So to establish a field, we must first click here and click Add Field. A field are multiple data entries where you can input different data sets. We will be adding multiple different fields for Accents 2016. I will go through the steps to make each field. As you can see in the attribute table, there is already a section for ID, thus we will not be making an accent ID field.
The first field we will be creating will be the date. After we selected Add Field, it will prompt a window titled Add Field to appear, with name, type, and field's properties. We will be naming it date, and the field type will be date. The type dictates the field property. Select OK. This has caused our first field to be created. The second field will be time of day. Go through the same steps we did to create the first field. However, instead of naming it time of day, name it TOD, because we cannot spell time of day in its entirety. Select the field type as long integer to be able to input up to 6 numbers. Time and day and date are 2 separate fields because when we go to analyze the map for different accident statistics, date and time are 2 separate factors. In the field properties, input the number 6. The precision entails the amount of numbers that can be inputted into this field. The third field will be day of week. Once again, go through the same steps. Name it DOW. The field type will be text because you will be writing out the specific day of week with letters and not numbers. The fourth field will be accident type. Name it ACC_type. Also for this field type, the field will be text. The fifth field will be severity score. Name it severity due to the entire name not being able to fit. The fields for this will be long integer because of the capability to input large numbers. In the precision box, input the number 6. The 6th, 7th, and 8th fields will be similar to one another. They are an extension of the severity score. The 6th field will be titled fatalities, after the number of fatalities caused by the accident. The 7th field will be SER_INJ for serious injuries, after the number of serious injuries caused by the accident. The 8th field will be titled SLT_INJ, after the number of slight injuries caused by the accident. Each will be using the type long integer, with approximately 6 as the precision. It does not matter how high the precision is. However, it does matter if it is too low. Thus, it will always be a good idea to input a large number for precision. After establishing the attribute fields, we will finally start creating our accident pinpoints. I already have the editor toolbar on my homepage, as you can see here, but most of you will not. Thus, you will need to open it. Go to the Customize tab, go to Toolbars, and then go to Editor. Click on it, and it will appear on your homepage. The Editor toolbar will allow you to create and place the points on the map for the accidents. Now click where it says Editor, and this will prompt editing functions to open. Click on Start Editing, and this will prompt a window to open that says Start Editing. From there, you will select the data layer you want to edit. We will be using the same data layer we created during this tutorial as an example. Click on Accidents 2016, and then click on OK. You are now in editing mode. Next, you must open the Create Features tab and the Attributes tab. Under the same editing functions, go to Edit Windows. From there, open up Create Features and open up Attributes. In this Create Features window, select 2016. This will open up options in the constructions tools at the bottom. The two options are point and point at the end of a line. We will only be using the point construction tool because we want to individually pinpoint each accident. Select point. You will now see the symbol for Accident 2016 on the map, but first we must move this over. You will now see the symbol for Accidents 2016 on the map. The Attributes tab is located under the same editing windows. I've already selected Attributes. This will cause a table to open that will allow you to input all the information for your attribute fields. This is important because this information is what will help you identify your accident later due to its different characteristics. The process we used to establish the accidents on the map was to have an Excel file with all the accident details already organized by town to town sections, along with data categories for the attributes and locations identification. To keep it simple, I will only be mapping an accident from Swakopmund to Walvis Bay. This example accident will be 15 kilometers south of Swakopmund. To map this, we will start at the city center of Swakopmund, which is the blue circle on the map right here. We'll open up the measuring tool, which we learned about previously, and start measuring 15 kilometers south of Swakopmund. So to start, we'll start right here and start clicking. And remember to stay pretty precise, because if not, something like this will happen. So we must start over. And stay right close to the road. And once we've reached approximately 15 kilometers, so right there, and once we reached approximately 15 kilometers, we will place a point there. So to place a point, we go to Create Features and place a point right there. It will now be an established feature on the map. Once it is created, go to the Attributes tab and input the information accent. For this example, I will say the accident occurred on January 1st, 2016, so 01/01/2016. The time of day was 1700 on a Friday, and it was with an animal with a score of 100 with 3 slight injuries. And the accident ID will be 123456. Now that completes the first accidents. Congratulations, you have pinpointed your first accident. From there, you will continue to map all your accidents. After the accidents have been mapped, you will produce your accident map. From this map, you can create a severity map using the features I spoke about earlier with the Select Analysis tool. Also, you can create maps of just animal-related accidents, accidents only on the weekends, and more, using the same Select Analysis tool. This process is a lot of manual work with manual imputation of information, as well as pinpointing accidents. This takes a long period of time, but as soon as you get the hang of it, the efficiency of pinpointing will be great. Once you have finished pinpointing your accidents, or want to take a break, you must save your edits under the editor tools, as well as save the entire document. To save your edits, click on Editor, and either click on Save Edits or Stop Editing. The first option will save your edits, but not close out of editing function. The second option will prompt a window that says, do you want to save your edits? Select Yes. This will save your edits and close the editing function. It is crucial to save your edits due to the program closing sometimes. After you're done saving your edits, remember to save the entire file. Before we finish with this tutorial, I just want to inform you that ArcGIS does have some of its difficulties. The program does stop responding at times and can operate very slowly due to the large file sizes. Also, some glitches do occur. Do not stress because it will work out. Just remember to save often, just like I am doing now. Ta-da! Thank you so much for watching this tutorial. I hope it has been informative and you have learned how to use the software and how to map accidents on ArcGIS. If you have any questions about the procedure, please reach out to mvafund16@wpi.edu. Thank you once again, and I hope you have a great day.